Have you ever spent hours managing complex data pipelines and scheduling jobs? What if your tables could update themselves automatically? Well, Snowflake's dynamic tables can do just that. In this video, I'll explain what dynamic tables are, how they differ from traditional scheduling and building pipelines, how they work, and hands-on demo on Snowflake. Let's get started. What are dynamic tables? Dynamic tables in Snowflake make data transformation easier by handling everything automatically. Instead of setting up tasks and schedules to update your data, you just define what the final table should look like. Snowflake then manages the entire process, keeping your data fresh, efficient, and cost effective without any extra work. Why dynamic tables are beneficial? No more complex steps. Instead of writing detailed transformation steps, you just tell Snowflake what the final data should look like using SQL and it figures out the process for you. Automatic data flow. You can connect multiple dynamic tables to create simple or complex data pipelines. Snowflake automatically manages when and how they update based on your freshness settings. Faster performance. Instead of refreshing entire tables, dynamic tables process only new or changed data, making updates much quicker and more efficient. Easy to switch between batch and streaming. With just one command, like alter dynamic table, you can adjust how frequently your data updates, balancing cost and freshness. Built in monitoring and management. You can track and control dynamic tables through Snowsight or use programmatic tools to build your own monitoring systems. Always up to date data. A dynamic table automatically updates based on its query. So you don't need extra tables or custom transformation code. However, you can't manually edit its data. It refreshes itself based on the defined query. This means less manual work, fewer scheduling headaches, and more reliable real time data updates. How dynamic tables work? Here are the steps. Define your query. Create a dynamic table by writing a SQL query that transforms data from one or more existing tables. Automated refresh. Snowflake runs this query on schedule, automatically updating the dynamic table with any changes from the source tables. Efficient updates. Instead of rebuilding the entire table, Snowflake detects changes and merges only new or modified data. Compute resources. The updates use compute power from a warehouse you assign to the dynamic table. More frequent updates may use more resources. Set data freshness or lag. You decide how up to date the data should be, like 5-minute lag for near real time updates, 1 hour lag for cost savings with less frequent updates. You can balance cost versus freshness. If your data doesn't need constant updates, choosing a longer lag time helps optimize costs. In short, you define what data you need, and Snowflake handles when and how it updates. Now you know when to use dynamic tables. Let's talk about when not to use dynamic tables. If you need precise control over refresh timing, like specific times of a day, dynamic tables might not offer enough flexibility. If your transformations require stored procedures or non deterministic functions, dynamic tables won't support those. If you need full control over task executions and status tracking, manual orchestration with streams and tasks is better. Dynamic tables don't support external tables or streams as resources, so they are not suitable if you need data from external storage. For tracking historical data or point in time snapshots, manual methods offer more control. If your transformations are complex and require different computational resources at each step, manual pipelines might be more flexible. In these cases, you can still manage your data transformations using streams plus tasks or create table as select with manual scheduling or orchestration tools like ADF, AWS Glue, etc. Time to do some hands-on. Here are the steps we'll run in Snowflake. Create a base or source table and insert records. Create a dynamic table that transforms data from the base table. And then insert new data into the base table and observe automatic updates. Let's do that. Let's open Snowflake. I created a sample DB called Retail DB for our demo purpose. Now let's follow the steps that we just discussed. For step 1, let's create a base table. Now what? Insert records. Execute it. Okay. The table name is sales data. 10 records inserted. Let's quickly do a select on top of this. Here is your sales data table. Alright, now what? Our step 2, that is to create a dynamic table. Here is the query. So what exactly we are doing here? We are creating a dynamic table that is with a simple create dynamic table, your table name, and you're giving a lag. So why is this lag? Say for example, this is your base table, right? For any change, and real-time changes happen on your base table. So your dynamic table purpose is to show those changes dynamically in the table that we create. When we say dynamically, we are putting a time to it, that is 5 minutes lag. So the moment you have a change in your base table, after 5 minutes, you can see the same in your dynamic table here. Lag equal to 5 minutes is for that purpose. Now, you can adjust it the way you want, 1 minute or 1 hour. For demo purpose, let's make it 1 minute. This is the simple select statement. Select customer ID, count of the orders, and sum of the total amount. So this is the summary table that I wanted to create as a dynamic table, which doesn't have any complex transformation. It's a simple aggregate query of your base table data. Let's execute it. Your dynamic table sales summary successfully created. Let's see the data in it. The table name is sales summary. Execute it. See, the total order count and total amount grouped by customer ID. So this is what we have got. Now let's update the base table to ensure our dynamic table is working as expected. I'm writing an update statement here or an insert statement. Anything that creates some change in the base table. Let's see how it works. Insert it. Why am I still seeing my dynamic table query output? Let us re-execute the select star from sales data. See, with 101, you're seeing 2 records, 250 plus 150. So the expectation is to see the sum of total amount here and also the order count. Let's give it a minute before we execute the dynamic table. Execute it. Look at it. So the order count is total 3, so somewhere we missed another 101. Let us look at it. Oh, customer ID, right? Let's sort it by customer ID. We have total 3 orders, 1 plus 1 plus 1. 3 transactions. And the total is also 500. So that's exactly Your dynamic table dynamically shows you the transformed data without even the hassle of creating streams and tasks and CTAs. Without dynamic tables, you rely on a set of manual processes and external services for data transformation. For example, streams to track the changes in base tables, tasks to schedule and automate running SQL transformations, staging tables for holding intermediate results before applying final transformations. Manual refreshes or external orchestration tools like ADF, Airflow, or others to manage the scheduling, monitoring, and error handling for the pipeline. That's a wrap on Snowflake Dynamic Tables. They're a game changer for automated transformations. How would you use dynamic tables in your projects? Drop a comment below. And if you found this useful, like, share, and subscribe for more Snowflake content.